Hi guys, how's it going? This is Sierra, and today we're going to be talking about the different types of variables you would find in object-oriented programming in Python. Okay, so OOP variables in Python. Okay, and there are three variables that I wanted to talk to you guys about today. There are instance variables, there are static variables, and there are local variables. Okay, and instance variables are object level variables, static variables are class level variables, and local variables are method level variables. Okay, and why don't we start off by talking about instance variables. Okay. So if the value of a variable, okay, the value or property of an object, if they change from object to object, so if the value of the properties are different for every object that you create of a certain class, then those variables can be considered instance variables. Okay, and I think I mentioned in another video that for every object, another copy of the instance variables will be created so that you can assign different values to it. Okay, and let me do an example. So we're going to create a class called person. Okay, we're going to define our constructor. It's going to take in self. Okay, we're going to say self.name equals Sarah. It's not very personalized because for every object you create, it's going to be Sarah. Self.age equals 30, and self.hobby equals painting. Okay, and okay, so inside the constructor, okay, using the self variable, okay, we can automatically add these variables to whatever object we create. So if we create an object of the class person, Sarah, okay, because that's her name, I'm going to say it's an object of the class person. Okay, it's all good, and we're going to print Sarah dot dict. Okay, and this dictionary will contain all the attributes, right, all the variables that are defined for the object. Okay, it maps the attribute name to its value. Okay, so the attribute name is name, right, and the value is Sarah. There's a variable called age, its value is 30, hobby points to painting. Okay, so these variables will automatically be added to the object, and if you create an object called Bob, okay, it's also person, and if you print the same thing, Bob dot dict, right, you also get name is Sarah, age is 30, hobby is painting. It's not very personalized because we're putting in specific strings over here. Okay. Cool. And inside the instance method, you can also use the self variable, and you can declare instance variables inside instance methods as well. So if you wanted to define a class called test, okay, we're just testing it. We're trying to prove something here. Okay, and we're going to define our constructor init. Okay, we're going to initialize two variables here. Self.a is going to be equal 10, and self.b is going to equal 20. Okay? Cool. Okay, and now we're going to define an instance method, def method 1, okay? It's going to take in self, and we're going to define another instance variable, okay? It's not in init, it's going to be inside method 1, okay? So this is where you can define instance variables. You can define it inside the constructor using the self variable. You can define it inside a method also using the self variable like this. So self.c equals 30. Okay. 30. And if you were to create a test object, okay, because that's the name of the class, test, and the reference variable is going to be t. Okay, so this is the syntax. This is how you create an object. Okay, and if you do t dot dict, you get A and B, okay? And this is because whenever you create an object, this init will run, okay? This will get executed. So if you were to print execution of constructor, you get execution of constructor, and you get the properties that you have currently. Okay, and this is why we define and initialize variables in the init method, because it automatically does it for us. Okay, but I want to see our C in there as well, right? Our self.c. Okay. So if any instance variable is declared inside the instance method, okay, the instance variable will be added to this list. It'll be initialized after you call the method. Okay, so if you call a method by using a reference variable, you can do that. And we're going to do t dot method 1, right, because that's the name of the instance method. And it doesn't take in any other arguments. Okay. Okay, so we define an object. We create an object, okay, a test object, call it T. Okay, we're printing the properties, okay, and then we get A and B, and then we call the method 1. And then we're going to print t.dict. Okay, now you get A, B, and C, because this variable is initialized right after you call this method off of the T reference variable, which is an object of the class test. Okay. Cool. And you can also define instance variables not only in the constructor, not only in instant methods, but you can also do it outside of the class if you wanted to. Okay, we're defining another class called test. Okay, another class called test, and we're defining a constructor init. Okay, also takes in self. Okay, we're going to do the same thing. Self.a equals A, right? actually, let's do 10. Self.b equals 20. Okay. Cool, and we're gonna do the same thing. Method 1. Could have copy and pasted. Okay. But I'll just write it over. Okay. So T is an object of test. Okay. T dot method 1, right? And then we're gonna print T dot dict. And you expect the same result as we get here, right? You do. You get A, B, and C. But I want to create another variable called D, and I don't want to really do it inside the class test or inside any of the instance methods. So I'm going to do it outside the class. Okay? And here I can't use the self, right? So I'm going to use this reference variable I used here. Okay, and I'm going to say t.d, okay, equals 40. And I run it, and everything's all good. Now we're going to print t.dict, okay, and we get A, B, C, and D. Okay. So that's what's going on there. So now let's talk about how you can access instance variables. So if you have a class test, okay, and we said that t equals test, alright, if you do t.display, actually, if you print t.a and t.b, okay, you're accessing it via the test object we created here, t, right? We get 10 and 20. Okay. And if you want to delete an instance variable from the object, okay, if you would like to do it inside the class, right, if you would like to delete it inside the class, you use self dot the variable name, del self dot the variable name. Okay. We're going to define another method here, method 2. And we're going to say del self dot c. Okay. And then I'm going to print t dot dict. Okay, I didn't call the method, so that's why we're getting the same result. T dot method 2. Okay. Then you run it, and then you get A, B, and D. We deleted C. Okay. Now, if you change a variable that is initiated, right, you're not gonna see them unless you call the method. Okay, that's what happened here, right? When I just like printed t.dict, right, I got the same result, A, B, C, and D. But once I called the method 2, which is where I deleted self.c, right, I didn't get C anymore. Okay. And you can also delete it outside the class. Okay. So, for example, if I wanted to delete A. Okay. So I'm gonna do del, right? T.A. And now we're gonna print t.dict. And we get B and D. We already deleted C, now we deleted A, so now we just get B and D. Okay. Cool. So I want to just say one more thing about instance variables. Okay, so if you define a class test, okay, we're defining the constructor init self.a equals 10, self.b equals 20, self.c equals 30, self.d equals 40, right? And we're creating two objects, t1 equals test, t2 equals another object of the same class test. Okay, all's good, all's well. Okay, we're deleting t1.a, okay? And now we're gonna print t1.dict. Okay, and we got B, C, and D. We deleted A. But the thing is, you see, if you want to print t2, okay, t2 is also an object of the class test. And you do t2.dict. Okay, you get A, B, C, and D. Okay, so we're gonna make a little note here. And so the instance variables that are deleted from one object, okay, it's not going to be deleted from the other object because a separate copy of the instance variables are going to be created for every object. So what you're doing here is you're modifying the instance variable that is associated with the object t1, not with the object t2. So that's why you get A, B, C, and D when you print out the properties of the object t2. Okay? Cool. Okay. So I think that's enough for instance variables. Let's talk about static variables right now. Okay. And so you know how in instance variables, the values of each variable change, right, from object to object, right? So you could, in my previous video, I defined class, student, and the names of the students were all different, right? So that's how we know that the values can change, right, from object to object. But if you don't want them to change from object to object, right, you can declare these variables, these static variables, right, inside the class, but outside of the methods, right? Okay, so here only one copy of static variables will be created, and this copy is going to be shared with all the other objects of that same class. Okay, and we're gonna define another class called test yet again. Okay, class test. Okay, x equals 10, and def init. I'm doing it outside the methods but inside the class. Okay, the constructor is where you define instance variables. Okay, but this is static variable. Alright, so we're just going to say self.y equals 20. X equals 10, self.y equals 20. Okay, we're going to create another two objects, t1 equals test and t2 equals test. Okay, and we're going to print t1 is going to be equal to t1.x, right? Or actually, we're going to print the two variables that we find in t1. Okay, so t1.x and t1.y, right? Okay, we get 10 and 20, right? X equals 10, y equals 20. And we're going to do the same for t2. Okay, we get t2, 10 and 20, right? They're the same variables. Okay, but here, okay, you can access static variables either by class name or by object like the reference variable, right? So you could just do t1 dot like x, right, for static variables, but it's not recommended. Okay, it's gonna be a little confusing, right? So let's just use the class name test, right? And we're gonna change the value to 876. Okay, and we're gonna change t1's y, right? This is an instance variable, and we're going to change t1's y to 90. Okay, and now let's print t1 and t2 again. Okay, or let's do another cell. Let's run that, and then okay. So what do you get here? You get 876 and 876. What does that prove? So the first value that we printed was t.x, t1.x, and t2.x. So that means that these are the same, okay? Because I changed the static variable. There's only one copy of this x, and that copy is shared by any variable in the class. Okay, it's shared by both t1 and t2, so that's why it's the same. So when you changed it for the test, it changed for both t1 and t2. Okay, but here I changed t1.y, okay, the variable y that's associated with t1 to 90. Okay, and I got 90. But I didn't get 90 here because a separate copy was created for t2 because it's an instance variable. And the instance variable stayed the same, 20, right? So we got 20 here for t2. t2.y equals 20, but t1.y equals 90 because that's what we defined here. Okay. Cool. And there are different places where you can define static variables. I'm not going to define them all in those different places right now, but you can define them inside constructor by using the class name. So if you wanted to be like, so if the class name was test, then you would do test dot whatever variable, right? Equals whatever. So this is where you can define it. Okay. Let's just use 90 for all the things that I'm trying to show here. Okay, so I'm talking about the different places to declare static variables. Okay. Okay, you can define it inside instance methods, also by using the class name. You can define it inside a class method by either using the class name or CLS variable. Okay, we'll talk about that now though, because that might be a little confusing. Okay, and we can use it inside a static method using the class name. Okay, and we'll talk more about class methods and static methods in another video, but basically you can define methods as class methods or static methods by using the same symbol we used for decorators, right? That at, right? Okay. So you can say at class method, or you can say at static method. Okay. And we'll talk more about these in another video. Okay, these are going to be about different methods in object-oriented programming. Okay, but that's another place where you can declare static variables. Okay, so these are 4 places where you can define static variables. Alright. And you can access them inside a constructor by using the self or a class name. You can access them inside the instance method by using the self or a class name. You can access them inside the class method using the CLS variable or class name, right? So you're always going to do like CLS dot or the class name dot or self dot, right, to access them. So if you wanted to print it, right? Okay, let me jot these down for you. So inside the constructor, using self or class name, we can access it inside instance methods using self or the class name. You can access it inside class methods using the CLS variable. Okay, we'll talk more about that later in another video. Or class name. Okay. Inside static methods by using the class name. And last but not least, from outside the class by using the object reference, right? This is considered, so when we're creating an object here, T1 is considered the object reference, right? The reference variable. Or class name. So these are all the different places where you can access static variables. So here we talk about declaring static variables, but here we talk about accessing static variables. Okay. Okay. And you can also modify static variables anywhere within the class or outside the class by using the class name. But in class methods, the CLS variable should be used. Okay. And let me just give you an example because it's been a while, right? So class test, right? A equals 777 maybe. Okay, we're defining the class method. Don't worry about this just yet. Okay, we're defining method 1. Okay, instead of self, we're passing in CLS. It refers to the entire class itself, not just the object, right? But here it refers to the entire class. So cls.a equals 650. Okay, this is going to be a static method. Okay, def m2. Okay, it doesn't take anything. We're just going to say test.a equals 999. Okay, so this is where we're modifying static variables, right, inside static methods, right? So when we're defining m3, method 3, okay, self, right, not static anymore, and we're just going to say test.a, right, we defined it here. It's going to be equal to, instead of 999, we're going to say it's 1,000. Okay. Create an object, test. We're going to print test.a. What do you get? 777. We're going to do test.m1. Right, m1 the class method. So we're going to use the class name instead of the object name. Right, we ran it, and now we're going to print test.a again, and we get 650. Okay, now if you wanted to print, okay, first, wait, let's use the object name, the reference variable, to call method 3, m3. Okay, so this doesn't get changed unless you call the method. So we call it, and now we're going to print test.a again. And we get 1,000. Okay. Okay, so let's talk about class methods and static methods. Okay, so the difference between the two, okay, so both of them can be called on the class itself, right? So we use test.a, right, here, rather than just an instance of the class or like the object, right? So class methods take CLS as a parameter, right, instead of self, so it refers to the entire class, right? It has the ability to change the entire state of the class, whereas the static method does not. Okay, so if you change the value of a static variable by using either the self or object reference variable, then the value of the static variable won't be changed. Okay, just a new instance variable with that name is going to be added to a particular object. Okay, let me give you an example. So if we have class test, okay, a equals 10, okay, we're defining method 1, takes in self, instance variable referring to the object, self, right, self.a is going to equal 80. We're creating an object, t1 of the class test, t1.m1, running that. And we're going to print test.a, and we're going to print t1.a. Okay, we get 10 here, and we get 80 here, okay? So the static variable is not changed when you use self, okay? Because we're not changing the class variable here, the static one, right? So we're just creating a new instance variable with the same name, and it's going to be added to the particular object that we created here, which is t1. Okay? And if you want to delete a static variable, you can just go like del class name dot variable name right? But inside a class method, you can also use a CLS variable. So if you wanted to do del.cls dot variable name, okay, okay, and if you try to delete a variable inside a class, right, not in any of the methods, using an object reference, you're going to get an error because it's not associated with just that object. It's associated with all the objects. So if you see class test a equals 10, and create t1 equals test, and if you want to delete t1.a, you get an attribute error because A does not belong to just T. Okay, if you wanted to create another object like T2, T3, T4, this would belong to all those objects because it's not defined in any instance method, right? So that's why you would get an error. Okay. So let's talk about local variables now. I think we're done with static variables. Okay. Okay, sometimes you need to declare variables inside a method directly, okay? Maybe to meet like some requirements, right? And these types of variables are going to be called local variables or temporary variables because they're not instance variables because we're not using the self variable, or we're not using self.variable name, we're just doing the variable name, right? Just like a regular variable. Okay. And these local variables are going to be created when you execute the method, and it's going to be destroyed once the method completes. Okay. So, and also you cannot access them from outside the method. So if you were to define another class called test, and I know you might be getting bored of test, but it's easier to understand, right? Okay, so method 1, self a equals 1000. So I'm not using self here, and we're just going to print a. Okay. I'm defining method 2, also self, and then we're saying b equals 2000, and we're going to print b. Okay. T equals test. Okay. It's an object, test. Okay. T dot method 1. Okay, 1000. But what if we were, okay. And let's call method 2 too. So T dot method 2, 2000. Now, if we were to print a inside method 2, we get a name error. Okay, because a is a local variable from method 1. Okay, it's not an instance variable, so you can't access it from method 2. Okay, you can't access it outside the method in which it's defined. Okay. Cool. So we talked about the different type of object-oriented programming variables in Python. Okay, I think we went through a nice overview. Okay. We talked about instance variables, which are object-level variables. We talked about static variables, which are class-level variables. We talked about local variables, which are method-level variables. We talked about how you can define and access all of these different types of variables, okay, inside the class, outside the class, using the reference variable, right, and all these things, okay? I hope you learned something new today in OOP, in Python, okay? And don't forget to stay curious.